Listen to the problem hidden inside this landing film. Apollo 11 is descending toward the moon when the computer flashes 12:02. Armstrong asks Houston what it means. The crew has not seen this alarm in training. Mission Control now has seconds to choose. Keep descending, or order an abort that ends the first moon landing attempt. The first evidence reward is crucial. 12:02 did not mean the computer had stopped steering. It meant the executive program could not allocate another work area because too many jobs were queued. The computer restarted, kept its critical guidance tasks, and discarded lower priority work. That distinction turned an unknown alarm into a decision. If Mission Control says go and the alarm is hiding a guidance failure, Eagle may keep flying toward the surface without trustworthy navigation. If Houston says abort and the computer is healthy, the mission ends for a recoverable overload. The decision is asymmetric. One error risks 2 lives. The other throws away years of work but brings them home. There is no pause button while engineers debate. Eagle is falling along a powered descent trajectory. Radar data is arriving. The computer is steering the descent engine. Communications have already been uneven. Each second lowers the spacecraft, consumes propellant, and shrinks the time to diagnose the code. The choice has to move at flight speed. The Apollo guidance computer was tiny by modern standards. Roughly 2,000 words of erasable memory and 36,000 words of fixed-core rope memory. Its power was not raw capacity. Its executive software ranked jobs by priority. When overloaded, it could restart and resume the essential tasks instead of freezing everything equally. The hardware was not simply failing. A rendezvous radar switch configuration caused repeated requests that added needless work during descent. The computer was being interrupted faster than it could comfortably serve every request. The alarm reported that overload. The deeper question was whether the priority system was still protecting the calculations that mattered for landing. In the back room sat Jack Garman, a 25-year-old engineer who had prepared a list of computer alarms. Guidance officer Steve Bales asked for the meaning. Garman recognized 12:02 and knew the restart logic. That preparation mattered more than rank. The call moved from specialist to controller to Capcom. They were go on the alarm. The famous phrase sounds like one instant opinion, but it traveled through a disciplined chain. Garman supplied the technical interpretation. Bales owned the guidance judgment. Flight control coordinated the room. Charlie Duke, the capsule communicator, spoke to Eagle. The structure prevented a noisy room from sending competing instructions to 2 astronauts already overloaded. Houston answers. They are go on that alarm. The decision is not that alarms do not matter. It is that this alarm has a known failure mode. The essential programs are still running, and the telemetry remains consistent. Apollo 11 continues. Seconds later, another 12:02 appears. The team must prove its logic was not a one-time guess. The alarms repeat. 12:02, then 12:01, then more 12:02 calls. Both codes point to executive overload in slightly different resource conditions. Mission Control keeps checking the same evidence. Guidance is active, the restart is recovering, and key values remain sensible. Consistency turns the first brave answer into a defensible operating rule. A common retelling says the computer simply ignored the problem. That misses the engineering achievement. The executive program recognized overload, restarted, and preserved selected critical programs near where they had been. It shed work that did not deserve equal priority. The save came from deliberate fault-tolerant design, tested before the mission, not luck alone. Even after the alarm decision, the landing is not safe. Armstrong sees that the automatic path leads toward rough terrain near West Crater. He takes control of attitude and flies across the boulder field, searching for a clear patch. The computer decision kept the landing possible. The pilot decision now determines where Eagle will touch down. Mission Control calls 60 seconds of propellant, then 30. Those calls were not a literal countdown to instant engine shutdown, but they marked the low fuel thresholds the team had planned around. Armstrong is still translating over the surface. The earlier decision to continue has now committed everyone to finding a safe spot inside a narrowing margin. A contact probe touches the moon. Aldrin calls contact light. Armstrong shuts down the descent engine. Dust settles, and Eagle remains upright. The mission report records touchdown at 102 hours, 45 minutes, 40 seconds. The decision chain has survived computer overload, repeated alarms, rough terrain, and low fuel. Jack Garman deserves the credit NASA gave him, but the stronger story is a system. Programmers built priority and restart behavior. Testing made the behavior knowable. Garman prepared the codes. Bales judged the guidance data. Duke transmitted one clear answer. Armstrong and Aldrin kept flying. One decision worked because many earlier decisions made it informed. The lesson reaches beyond Apollo. An alarm is not a verdict. It is a compressed report. Good operators ask 3 questions. What resource failed? Which essential functions survived? And whether the system is recovering or degrading. Mission Control could say go because it answered those questions faster than fear could turn uncertainty into an unnecessary abort. The opening promise is not repaid. 1202 meant overload, but the guidance computer was shedding lower priority work and preserving the landing. Garman recognized the code. Bales backed the interpretation, and Houston told Eagle to continue. The choice did not save Apollo 11 by dismissing danger. It saved it by naming the danger accurately. Apollo 11's alarm decision lasted seconds. Its foundation took years. Software architecture, simulations, checklists, and a communication chain built for pressure. That is why one young engineer could give a short answer without making a reckless guess. Subscribe for one impossible choice, and the evidence behind it, every day.